So now this question is complex. It's complex, but if you've been following what we've been doing before, then it should be easy for you to do. Now we are going to represent all of this on a single graph. Now the question we've been doing, we've been seeing question in which we have just one inequality, two variables we represent on a graph. Now I want to find a single solution that will represent everything. So how do we go about this? Now I call this simultaneous inequality, because this is like inequality 1, inequality 2, inequality 3, inequality 4. But we don't call them inequalities, we don't call them inequations, we call them constraints. Constraints, that's what we call them, constraints. So this is constraint 1, this is constraint 2, this is constraint 3, and this is constraint 4. So we are going to take the constraint one after the other. So let's take constraint 1 now. Taking constraint 1, now for constraint 1 we have 2x plus 3y less than or equals to 26. Now what we are going to do, it looks like that normal one we've been doing, so we'll try to make y the subject. So we have 3y less than or equals to, if this one comes here, minus 2x plus 26, minus 2x plus 26. So we divide all through by 3. If we divide all through by 3, that means y is less than or equals to minus 2 over 3x plus 26 over 3. So now we assume it were an equation. So assume it were an equation. So if we assume it were an equation, we have y equals to minus 2x over 3 plus 26 over 3. So from here we will now look for y when x is 0. So find y when x is 0 for constraint 1. So we have y is equals to minus 2 over 3 times 0 plus 26 over 3. So this is y is equals to 0 plus 26 over 3. So what will 26 over 3 give us? 26 over 3 will give us 8.67. So that means y is equals to 8.67. So when x is 0, y is 8.67. Now let's look for x. Now find x when y is 0. So we are using this. Find x when y is 0. So when y is 0, we have 0 equals to minus 2 over 3x plus 26 over 3. Minus 2 over 3x plus 26 over 3. Now if this one comes here, we have 2 over 3x is equals to 26 over 3. Now if we cross multiply, we have 3 times 2x is equals to 3 times 26. Now if we divide both sides by 3 times 2, which is 6, 3 times 2. So this cancels this, 3 cancels 3, 2 in 26, that's 13. So that means x is 13. So that means when x is 13, y is 0. Now let's summarize the coordinates for constraint 1. So therefore, for constraint 1, the summary for constraint 1, when x is 0, y is 8.67, and when x is 13, y is 0. Now that's the summary of the coordinates for constraint 1. Now let's take constraint 2. Now taking constraint 2 now, So this is constraint 2. We have x plus 2y less than or equals to 16. X plus 2y less than or equals to 16. So we'll try to make y the subject. We have 2y less than or equals to minus x plus 16. So if we divide all through by 2, so that means y less than or equals to minus x over 2 plus 8. So now that we've made y the subject, we can now assume it were an equation. So you assume it were an equation. So if you assume it were an equation, that means this becomes y equals to minus x over 2 plus 8. So you look for y when x is 0. So find y when x is 0. So if we do that, that means anywhere we see x, we put 0 plus 8. So this is 0 plus 8. So that means y is 8. So that means when x is 0, y is 8. Now we'll look for x also. So find x when y is now 0. This is still for constraint 2. So we are looking for x when y is 0. So this is 0 equals to minus x over 2 plus 8. Now if this one comes here, we have x over 2 is equals to 8. Now if we cross multiply, that means x is equals to 16. Now for constraint 2, therefore the summary of the coordinates for constraint 2 is that when x is 0, y is 8, and when x is 16, y is 0. So we have 2 points for constraint 1. We have 2 points for constraint 2. Now these are the points that we'll use to plot the graph. Now we have to observe this graph very well. We can see everything is positive. So I'll just try and maximize. I'll maximize this graph like this, because we are managing the space. Or let's use this other board. Let's use this other board to plot the graph. It's going to be more easier this way. So we'll be using this to plot our graphs now to maximize space. So now we have the y axis and we have the x axis. So let's see, let's observe. We have y positive, okay, we have more of y to that side, we have more of x to this side. So we have x, we have y. So the x is up to 16. We have x up to 16, so we have to be very careful to manage the space. And we have y, okay, we have x up to 16. We have y, the maximum value of y is 8.67. So let's see. So let's use 1 for y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I don't know if x can take 1, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, let's take the risk. So you should take it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yes, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's x. Then for y, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, now for constraint 1, these are the coordinates we are using. Now before we do that, we'll start with this one that's just single. Now this is x greater than or equals to 0. Now this is the origin. x greater than or equals to 0. X greater than or equals to 0. So that means it is cutting x when it is 0. So if it is cutting x when it is 0, so we have this axis. So now it is greater than 0. So that means we are interested in that part of x. We are interested in this part of x. So that means we shade this part of x. So this is what we are shading, this part of x. So that means this part represents x greater than or equals to 0. Now for this part, it is y greater than or equals to 0. So that means it will pass through y equals to 0. This is the y-axis. So it will cut y. So if it is cutting y, so it is greater than or equals to 0. So that means we are interested in the part above this part. So for y, we are shading this part. Now it is becoming complex. You have to, that's the advantage of using this video. You have the opportunity of replaying it. So this is y greater than or equals to 0, because it is passing through y equals to 0, and it is greater than or equals to 0. We are interested in the part above. So this is y greater than or equals to 0. So we've taken care of this and this. Now let's plot the graph for the first constraint. Now for the first constraint, when x is 0, y is 8.67. Now 8.67 is, this is 8, this is 8.5, so 8.67 should be somewhere here. When x is 0, y is 8.67, and when x is 13, for the first constraint, this is x is 13, y is 0. So we'll join those 2 points together. So joining those 2 points together is just a sketch. It's not, we are not expecting a perfect result. We are just trying to show the region. So this is for the first constraint. And if you check the first constraint, the sign is less than or equals to. Less than or equals to. So that means we are interested in the part below the line. We are not interested in the part above the line. So we shade this part off. Shade that part off. So this is for 2x plus 3y less than or equals to 6. So 2x plus 3y less than or equals to 26. So this is for the first constraint. Now I know it's becoming ugly. Now for the second constraint, these are the coordinates. When x is 0, y is 8. So this is y equals to 8 for the second constraint. And when x is 16, y is 0. So this is it, x is 16. So you join this and that together. Yes. So we join. So this one too is less than or equals to. Less than or equals to. This is the second constraint. Less than or equals to. So that means you are interested in this part. So you shade this part also. Shade this part. You shade the part that we don't need. Then you represent the inequality. The inequality is x plus 2y less than or equals to 16. You write the inequality close to the line. Now where the solution is the part that is not shaded at all. So we didn't shade this part, this part, this part, this part. So there is a quadrilateral. So this part that was not shaded represents the region R. So that means this is where you are going to find the solution to all these inequalities. So the region R represents the solution of the inequality.